Hello guys and welcome to Cloud Computing. This is our third live tutorial. I wish you will enjoy it. I have a very interesting thing to show you today about Docker containers and why we need them. So I will start now just showing you the old Stone Age of deployment, how we used to deploy software. So you can understand why we need Docker containers and why we need Swarm and why we need service stack and so on. So the first thing you will notice when you are using Docker container that you keep asking why I should learn about Docker container. Now actually in the Stone Age of deployment, like when we have like a bad software company and those guys, they want just to build a software for a client. And we will have like SQL developer, we have Python developer, and we have also the user interface developers who are going to build and ship everything into the MySQL database, into the application server, and also the UI guys, they need just to post all the UI component in a folder. Now the question was how we are going to deploy or take the whole software and we move it from the company side into the customer side so we can give him the software that he asked for. Now what we usually did, we just bundle everything and we package it. We just make one single package, and there is a developer, he will take this package and he go to the client side and deploy it. Now sometimes the server that the client has, it was like need some scalability. Maybe he's not using like us in the company where we build the software. Maybe he's using, for example, so many database servers because he has so many requests for the database. So the application should scale. So that was one of the big questions, how we can scale the application that we built in our laptops back at the company to scale to suit the infrastructure of the client in his data center. And then we will install the software in his server and we need to test it from all the client available in the company. Now 90% from the test integration and deployment I did in my life, they failed because there was like a bug. Maybe the SQL developer, he forget to run a patch file before we just bundle everything all together, or maybe he has not put all the dependency and the project, same as what we did in Lab 3. You have to, for example, clone the code and you have to install Python 3, you have to install pip 3, you have to install lib client, and you have to install everything. Now what if you forget at the customer side to install one of those dependency? The problem happened and the frustration happened, and everybody will start to go back again and deploy it. Now with Docker, the story is much better, and it is in different model, because now with Docker engine, all you need to do, all the SQL developer in the bad software company, all they need to do is just to ship the code and save it as normal inside the container. So we package everything inside the container. That container we take to the client company and we just build a Docker container. Now this means we have the ability to do continuous deployment. Once we change the source code, we just rebuild the container and we just run the container on the customer side. Plus we can scale the container up and down based on the need, and this is why we need Docker. I could understand why you don't understand why you need container, because you never done deployment and integration test before. So it's very hard for you to imagine how much this is really important issue to deal with in computing. Now the sweet things about all of this, now once you have the container, now it is much easier for you to scale the container up and down based on the demand, or you just modify the source code and the container will be modified according to your recent modification. You put everything in one single place instead of having so many packages around, and maybe it has different operating system than the operating system that we use in the first place in the company where we built the software, and so on. So for this purpose, now we should be able to understand why we need container in the deployment model that we have in the cloud computing. For today, I made some interesting tutorials for you so you can understand containerization and scalability and availability of the software. So the first thing we will do today, guys, just go now to the cloud console and we will start just doing some work on the cloud console. Now immediately after that, just now I access the cloud shell, which should be able from this button here, as I show you in the last lab, and we will have like Docker host, we have VMs running, and now we will see what we are going to do with those VMs. So if you don't have a Docker host VM, or you should start it, because I asked you to stop the VM at the last lab, just feel free to start it, and now make sure you access the VM using the console. Do you have any question, guys, about this so far before I start with the demo? I have like now a demo about the performance of one single virtual machine, because you might be asking, well, why I need container while I do have a virtual machine in the cloud? The answer for this, you see this Docker host, it is a VM, it's running in the cloud, in Google Cloud Platform. Now, what if the customer running Amazon Web Services? How I can take the whole VM to the customer site? What I need to do? Like I cannot share it in a Dropbox. I cannot share it in Google Drive. I need to carry the whole image from one place to another place, and there is no other way to do it. The only possible way to do it is just to build everything in that VM, in that virtual machine, as basically a Docker container, and you push the container back to Docker Hub, and you can pull the image from any place in the world. And this is the sweet thing about Docker container. Okay, I will fix the mic now, which is strange. And how you find the audio, guys, now? Just let me know. If you don't have a Docker host, all you need to do now is just create a new virtual machine and use the custom image that we have in the project DT228. Still in one side. We need now to fix those issues. Like, in the meanwhile, just go and create a virtual machine, guys, and you will be able to access it from the cloud shell. Interesting setting. Okay, just give me 1 second. I will cut off this and start again. See?
See you. Yeah.
I think I fixed the issue with the audio, guys, so check and let me know that everything is fine. All good now from your side? Yes, I'm using OBS. Now let me know before I start doing and drinking more coffee, okay? I don't know, like we could survive with it. You sent me something in a flask. Like there's so many things in a flask happening, like that's the first thing you do. Enjoy, I believe, like you really enjoy this tool, so I'm going to start to use it for more interactive sessions, and we'll do it for more activities and so on. Oh, the guy who said he sent me something, Patrick Redmond. Come on. Okay. Now, while we are fixing this fix issue with the audio, I would like now to start doing some business, because this will take time. Now, all you need to do now from the session, just to start GC Cloud Compute, and then will be SSH to the Docker host, or to whatever the name of the machine you have in your computer. Now this is the command that we need to use to access the Docker host. Now you should be able to see this. This is the lab where we did our lab 3 and lab 4, and we built the image. Now if you go and you just make sure that you have basically an image installed from before, just go and check Docker image. Now I don't want you to do anything at this case, but I want to show you a tutorial, a demo about scalability. Now imagine that this is my Docker host, and I'm going to access it from a customer website. This is the website where I will deploy my software. Now I have so many images running at the background. Now I want to see if this software is doing any good. So all the software seems to be running, and this is what we mean by service stack. I have so many services running in top of each other. So now if you go and access the main website, you should be able to see the application, the super complicated application that we did in lab 3 and lab 4. And then I have some metric information about this application. If you look now to this page, I'm not asking you to build all of this, but this is only for the purpose of the demo. Now look, here it's give me a specific metric about every single service running on the system. And how I do that, it's, if you are interested on this, I could push the whole demo code to GitHub, so you can just build it and install it. But it will take you the whole maybe weekend. It may take you 2 or 3 days to make everything working with this. Now beside that, I specify some alerts in my my service. Now I want to monitor the VM, and I want to make sure that my customer are getting the best service I can. So I monitor, for example, the CPU. If the CPU is more than 1.5, send me an alert. And I'm using this app, which is the Slack, in order just to push those notifications at real time. Now, maybe this not going to be clear for you before I show you what we mean by this application, because some of you maybe they have not joined it. So just to give you a sense, okay, I will show you now what is going to happen at runtime when we do some stress application, when we stress the website and we create so many requests, so many hits. I show you now in 1 second. Just let me put this page up here so you can all see you, for the people who never joined the Slack before or never use it. So this Slack is basically a push notification service. It's just the same as when somebody sends you a text message or a notification to your phone, but we use it. It's an free to use for now, just to demo how we can monitor a software as a service in the cloud, because I want him to tell me the server should be running 24 hours. So now this is what we am using, which is the Slack. Now if you look here, I have so many messages from you, I have so many interesting things, but I am interested in one specific issue. If we are all working as a team here, and just to maintain those services to be running and giving the customer the best effort and the best service, you will see now it will monitor those services, and it will give me an alert every time the service go down or every time the service is going up again. Now how we can do that? Now I am monitoring everything in this service, so you can see now I have so many charts about the performance of this server. Now what happened if I just run in the shell in a demo terminal, when I run a post request to that server with a specific delay, just to stress that server, just to make this server basically suffer and make this server not having a good time. Now while I'm doing that as well, I want just to stress to use another tool to give this server a stress test to see whether this server going to stand against, for example, the peak hour, where there is so many customers are requesting my server, buying for example buying things and doing some transactions and so on. So if I got now 3 million hits per minute or per 5 minutes, what this server should do. Now in the old days, what happened was the servers will go down and you have to go to the server room and fix it, and the website will be out of service. The same scenario will happen, guys, when you have a denial of service attack. You know what's a denial of service? When somebody just make the service or the server inaccessible by anyone. So to do all of that, just look now, observe the performance of this service as you can see here in the diagram. Plus I can monitor the Docker host, which is the whole hosting machine. I can specifically specify to monitor a specific Docker container. It will give me now so many information about each container in the Docker host system. Now the idea that we need to understand, I have now a virtual machine. It could be a machine, it could be a hardware, a parameter machine or a virtual machine. In top of that, now I can run a cluster of containers. I can run so many containers. Why? Because it's easy to deploy, easy to carry, easy to move from one place to another place. Now look now to how I deal with it. Now if you can see, now maybe all of you now accessing on the same URL, so the website start to complain, start the website like, look how it's now hard for me even to navigate and use this server, because there is a scalability issue. The server is not responding, the CPU is so busy and the memory is full. So what we should do, restarting the server is not good idea. Accessing the server from another location or duplicating the resources, creating another resources, adding a new server is not going to solve the problem, because still we have increasing demand and you will keep asking the manager, oh, buy me new hardware, oh, buy me a new server, I need an extra hard disk, I need an extra database. The database at server 3 is basically down for a moment. Now, all of these issues happened when you don't have a scalability in your mind. So what we do in order to scale the server up and down based on the needs that we have. Now look to the performance of the server. It's quite terrible. Like everything here is basically showing me with red. Like there is something seriously happening here. If this is a real server in production, I will be fired. I will lose my job. So how you could solve this issue? Now with the modification of the Docker engine, what you could do if you don't want to worry about too much about the resources and you have lots of resources, you can create what we call Docker Swarm. And Docker Swarm is basically you have a manager, and this manager have like 2 or 3 workers with him. Now once the manager gets more requests, he will start to delegate one of the workers to do the job instead of him. The other choice, if you have like a very good server, you bought a server for 10,000 euro, you have enough CPU, you have enough RAM, but you need to make the server the service scale up and down based on the need. What you could do is to use what we call Docker stack, and this stack, which is basically a cascaded level of containers bundled with each other, and they will be running at the same virtual machine, not in a Docker Swarm cluster. It will be in the same virtual machine or in the same machine, let's say. The easy thing with Docker stack, it's with one single command, you could scale the stack up and down based on the user demand. So if you are looking for multi-virtual machines located maybe in different data center, in different geolocation, your choice is to use Docker Swarm. Now, if you have one single server and you want just to basically upgrade this service and scale it up and scale it down, you could use Docker Stack. But in order to use Docker Stack, you need something called Docker Compose or Docker Compose, which is basically a UML file that specify, for example, I need a Docker container for MySQL, I need another Docker container for NGX, and those are dependent on each other, and we need to run them with each other. So they are dependent in both. And MySQL is very dependent on NGINX, and NGINX is basically dependent on the VM. Now, most likely I will be ending now because the performance is not going very well. I most likely need to restart this server because it's nothing really going very well here. Like I cannot even refresh the page. I cannot do anything. But restarting is not acceptable if you are talking about a production environment. So the solution for that now, guys, is to create a Docker Swarm. I will show you the same thing when we just make a Docker Swarm. Now, before I start doing the actual tutorial of Docker Swarm, I will just make I want to show you a quick idea about how those services are running at the background. Now, if you are using Edge Room or Wi-Fi, guys, you will face a problem with lag. I told you this. You need a decent internet connection to see the stream in very good quality. So this is nothing to do from my side. I have a lag in my web service because I'm running a script going mad, just hitting the server with so many requests. But nothing to do with you. Okay? So just to be clear about it, if you have a lag, this is a problem in your side. Maybe you are in Edge Room. If you are in Edge Room, I don't think you could be able to see anything from this tutorial. But now I have a huge latency at the Docker container running at my server. I have a serious problem that I need to fix. Now we need to wait a few seconds until I manage to show you one dashboard that I want to show you. I have no chance. Maybe I should restart the server, guys. I think this is the only choice now for me to show you what I'm intending to do. So I go back now to my Docker lovely host, and I will say to this guy, you are really tired, the memory is full, everything is going very mad for you, so I'm going to reset. Yeah, the image is laggy because I want it to be Johnny. Like, I am running a script at the background just to do something really nasty to the server. Like, I will show you what I was running. But don't do it at your computer because it's a very heavy traffic. You generate heavy traffic. That's why. Yeah, the image is laggy also in my side, guys, because the server is down. The server is having a trouble. We need to scale this guy because this guy, he cannot handle all this request. You understand me? Now wait until I manage to restart the server, and I will post this command to you at the Slack page so you can understand this in better form. So where is the channel? Now this is the channel. Where is the channel? The channel is general, I would say. And this is the script what I was running. Now don't run this in your computer, guys. This will break, like, this will destroy the computer because I'm running a random HTTP request with 30 million. I'm sending 30 million requests to that tiny little virtual machine there, and that's why it was stuck. Now I think the server is back, so from now on I will. You can feel free just to be careful about it, guys. Now you access it from here, but I will use the terminal, my terminal, to access the VM for visualization, so you can see what I'm doing at real time. Okay, wish that is clear. So now I move to that terminal and show you the terminal. So now I am in Docker host. You could access the same machine, guys, from the Google Cloud. Also, you could simply use the SSH session available here. If you don't like to use any of these methods, it's up to you. But just to make everything clear for everybody, I will use the terminal for this tutorial. Now, I understand that I have a problem with my service, so I need to now check all running containers. And to do so, I need to run Docker command just to see. That is basically interesting. And just to see all images, I have all images. Now I want to see all running containers, and I can see that I have CA, I have alert manager, I have node exporter, but I cannot see my little web. So if I go now to Chrome and try to access it, I cannot see the web service running. So what I should do, I will go refresh this page. Oh, there is nothing running. So it seems to be the service is running somewhere. Now also Docker give me the ability to see all the services that are not running or having trouble. So with using this command docker ps-a, you could see all the containers that they have issue with them. And I have another container which was causing the whole problem. It's called docker CPU stress test. It just gives the container the Docker machine, the Docker host, a hard time. Now this application, my web app Flask, this application is not working. Maybe if I should restart it. Now go and check Docker PS. Now go and do Docker PS -A to check if there is any dangling services at the background. So what I did, I just make Docker PS -A. Now to see the current running services container, I do Docker PS. Now, honestly guys, do you know the difference between Docker image and Docker container? Before we move and we create a swarm, we need just to understand the basic things. If you don't know what the difference between a Docker image and a Docker container, please let me know in the chat box. Okay. Guys, hello. Now if you go back, you should be able now to see the service, my lovely service running, and everything is fine, and the server is responding, and I have no issue or whatsoever with this dashboard with all the graphics and the performance that I have, because I restart all the services, everything is fine. Now if I just do another stress test, it will start to cause me problems, and I have to fix them, I have to worry about them. The reason that I have so many things running on this container, so I would be doing much better if I have another way of scaling this machine to make it running in perfect form. Now if you look to the Slack page, if you're seeing the Slack channel and you just focus with me and ignore the chatting, guys, like you confusing yourself and you confusing me. Now look to the Slack channel. Now start to give me some alert. Tell me now, monitor service, Docker Flask, Docker host alpha critical, the service is down. Okay. Now my web app container is down for more than 30 seconds. And imagine that this is the main app that you are giving your customer access to. Now monitor service down, and then service is down at all. So there is like something serious happening in this virtual machine, because there is so many requests, there is so many demand. Now go back to this. Now in the meanwhile, while I'm trying to address the issues that you have, guys, most of you in the chat, and basically you have two chats now. You have two chat channels, so I am a little bit confused where you keep slamming me with messages. Okay. Now from Google Cloud Console, guys, create a virtual machine, call it manager, and then create two virtual machines. One, call it worker 1, and the second one is worker 2. Okay, I will type this. Now it's better if you could use the stock image, the custom image that I have for you in my project, do DD228. Yeah. I think we need to slow down and start just focus on the content in the issue now and follow the instructions, guys. And I will start now to kill many processes from my machine because I don't want any more traffic happening from my side. My laptop start to complain, and this is not good. Quit anything that you don't need at the moment, and just go now focus, guys. Create 3 virtual machines. So one we call it manager, and the second one we call it with Docker image engine. Yes, with Docker image, which is the one I used before. So from here, God, like we did this like so many times, guys. Create an instance, and from the instance page, just select the name, call it manager1, and then call another VM with worker1, worker2. And now you feel free to use the custom image that I have for you before. So from here, I just do manager1. No, just call it manager. And change this. This is the button that you need to click. Change it to custom image. From custom image, now get the image that I have for you before. Select Docker engine and select this. Now don't forget to do allow HTTP traffic. Yes, Abdullah, I will repeat now again, just when they start to focus, because they keep talking and chatting and distracting me, and they are distracted themselves. Now, the difference between a container and a virtual, a Docker container and a Docker image. I was asking you guys if you know the difference between them. Now, before I answer this simple question, have you ever done like install Microsoft Windows from a CD-ROM? Have you ever done that? Just say yes or no in the chat box. Now, a Docker image is basically a CD-ROM of that operating system, of that container, a binary file that you can carry on from one machine to another. But the Docker container is basically that image executed in its own virtual environment. Is that clear, guys? So the image is like an ISO image that you basically get for Windows 2010, and the container, it's actually that laptop running at the background and basically doing some interesting things for you. All right, now in the meanwhile, all I need from you guys, just go and create 3 virtual machines. One, call it manager, and the other 2 call them worker 1. Any other question in the meanwhile? And when you finish, just report in any of these applications, just report that you are done. And this is like the dashboard that I was trying to show you in the last time, but I couldn't manage to. So in the last 30 minutes, this is how my container performance look like. Like, look for the container memory usage. That's really alerting now. If I have this container, or if this server basically in a real production environment, my manager will call me at midnight and they will say, Basil, go to the server room, see what the hell is going on with this server, because everything there is going so haywire. Like, look to the performance of my web app. Like 48 megabyte memory allocation, that tiny application which I have nothing in it, just only speak with the database. Like, this is something really serious now, guys. Now if you look to the CPU usage, even it's reaching 4% of the whole CPU, which is something I should really worry about. And this is why I made those alert management. When CPU high, when memory high, when high CPU, when there is low CPU, when a service is down, all of these should be basically notified to me at real time so I can fix them. So we understand we have now a serious scalability problem with this server. The solution to it, if you are rich and you have lots of money, go buy a new software, buy a new database, hire more employees. Now with the era of cloud computing, the solution for this is much easier than you think. All you need to do is go and create a swarm manager, and that manager will be handling the request to all the workers in the swarm, and those will be a virtual machine, you can call them. Now this is a virtual machine, it's not a container. Now each swarm node will run its own set of container, whether you are running one single tiny container or you're running a stack of container. Now can I ask you guys, do you know the difference between now a container and a stack? This is interesting, because before I start doing the actual tutorial. So do you know the difference between Docker stack and Docker container? Anyone, guys? +1 mark in the CA, +2 mark in the CA, €2, free coffee. Come on. Anyone? Somebody typing, so I have to wait. Okay. Now Steve, listen to me carefully. Now a container, it's one simple container where we run one simple service or a software inside it. Okay? Now when we speak about a stack, it's a composition of multi-service together. Do you remember what we did in Lab 3? In Lab 3 we have a Flask app, and that Flask app was speaking with a MySQL. So imagine that we have MySQL as a database, as a container, and we have that little tiny Flask app as another container, and we need them always to run together, because there is some serious configurations in that Flask app about the MySQL IP address, about MySQL password and username. If you just want to bundle them and run them as a composite component container, we call this a stack. So you run a stack of container cascaded in top of each other, and you run them in the stack as a stack, so they always work with each other. If one of those containers go down, the other will definitely go down. But with the stack, it's give me the ability now to do failover. Maybe you will be saying now, why I don't run 2 containers by myself and I manage them? Because managing them is not that easy. When you go and see, for example, in our case now, we have so many services running. Now look here. Now I have those services running, and it's not really healthy to keep managing those containers by yourself. So look, now I have 1, 2, 3, 4, 5, 6, 7 services. So performance wise it's not good, and it's not recommended to have such level of decoupled container. While they are dependent on each other, they are highly coupled, so you much better having them as a stack. Okay, as most of you now finish creating the VM and creating the manager one, the manager and the worker, now let us start doing some serious coding, and we create our first swarm, Docker swarm. Guys, it will be very interesting for you, but you have to listen carefully to what I am doing. Now, this is my VM. This is where my VM is running. This is where all my services are running. So here, where I can see everything running. This is my web app Flask. It has Prometheus, it's a monitoring service. It has a node exporter, Grafana, which is the graphic that you just show, the alert manager, which is the guy who give me alert and send it to Slack so you can see that the service down or not. As a simple demo, for the sake of demo. Now if I just do docker stop my web app Flask, now wait 30 seconds and just observe Slack. Just go now to Slack and see what's going to happen. Now I am in Slack now. Don't send me your bank account here, guys, because everybody now is saying no private messages, no cash. So I will wait now in Slack to see, and this is supposed to be the whole team, so we all need to address this issue. Now we need to wait 30 seconds because I'm telling the Docker swarm, yeah, after 30 seconds, alert me. So maybe I better now show you how we have this at real time. So let me put the two windows together as much as we can. Okay, that's not going to be bad. Now look, App General, which is an application I made myself, monitoring service is down. This is a big issue. Let's say I read this message, I was at home, I access, and now I want just to start it. The good thing about the alert manager, besides it showing me when everything is going to be down and when everything is going haywire, it will also let me know when the issue is resolved by myself or by somebody else. Now, alerting manager, monitoring a Docker swarm, all of these are here for a tool I use just to demo for you guys. You don't need to worry about installing them. What you need to worry about is that you're able to create a Docker container image. You are basically build a Docker image and run a container from that image and manage the container, like starting container, down, stopping container, removing image, adding image, and so on. So I don't want you to worry about all of that. Performance wise, everything seems to be still in bad shape, so I have now to start doing the solution that I am proposing. So from the terminal, I go back and just do this commands, docker swarm init, which means I'm starting a new swarm. Now once you do this, it will give you now interesting thing like this. It seems to be this swarm has been nationalized. This node, this Docker host node, is now the manager of this swarm. Now anyone from the world, any VM, any computer who wants to join this swarm, he needs to put this command in from the worker console. So what you need to do is to go back and access the worker from the console. Okay, let me show you how you do that. I just copy that command and go back to my console, and this is worker 1, right? I just create SSH session to this worker. You can't see the SSH session. No, you can't. Now you can. Now I will access worker 1, guys. Are you following me? Now, while the SSH session is established, Docker, it's GC Cloud Compute SSH. I want to access worker 1. So now I am in worker 1. Be careful, guys, when you deal with those things that you are in worker 1. Now paste this command that I just copied from terminal. So go back, take that command, copy, just a simple copy, and go back here and just do a simple paste. Now, the command in your case is going to be different. You see this token, the swarm token, it should be different. The IP address of the manager, it should be different. So don't copy my command. If you want, you can join my swarm, which I believe is really good idea. So now I will put this command in Slack so you can join my swarm. My node will be the manager and your VM will be the worker. Now you need to do this from worker 1. If you want to create your own manager and your own swarm, that's fine, but just for demo purpose, I want now just to add you all in my swarm. This is look not good. Is this the command? Press enter here and go back to terminal. Copy that. Okay, sudo reboot. I reboot the worker. Now let me do the same with SSH2 worker 2, that worker 2, and I will put the command for you guys just to copy and paste. So the command now in Slack, and it is also in YouTube if you are not in the Slack. Now copy that and just go and add the worker 2 into your swarm. Now you have to be careful about this because you need to have Docker already installed there, and you need to have Docker also that command, which is sudo user mode docker, and add your username as an admin, or just run that command with sudo. Now let me go back to my VM. I am now in worker 2, and again I will add this. You see, that's what I'm talking about. It will ask me now for sudo. So what I will do, I will just put sudo in front. Docker. Okay, this guy was in another swarm, so let me just quickly do this. Leave. Come on, with sudo. Now this guy is left the swarm. Because I was just preparing for this tutorial, I have this guy in swarm. Okay, now if from my manager, once I do docker node ls, I should be able to see this is worker 2. Leave worker 2. So many screen. Now from my manager, this is my manager, guys. Okay. Now docker node ls. This is will give me the people who are in all the nodes who are in my swarm. So I have docker host, I have worker 2, and if any of you run his command, he will be joining me into my swarm in no time. If and only if we have a specific communication between us. All right. Are we good about it, guys? Now let me go back and see why worker 2, why worker 1, this guy refused to join my swarm. I need to address this issue, and maybe this is a nice tutorial for you. Okay, so now I am in worker 1 and I will try to do the same. Okay, docker swarm leave, and now add the swarm. All good, guys, or you went home, or what happened? So you managed to create the manager and add the workers? I hope you did. And now from my manager, once I just do docker node ls, I should be able to have docker host. I should be able to see worker 1 and worker 2. Can you show worker SSH terminal? So we run that in worker 1. Yes, you run that in worker 1, and you run that in any worker you want to join my swarm as basically to be in my swarm. You run that command there. Now it might be possible hard because there is no internal network. If you are in the same zone in the cloud with me, you should be able to do so. If not, it might give you an error. So worth it trying it. I will ask, for example, Gabriel and the guys who I know, and Philip, who else? Johnny, yeah, Oshin, Redmond. Just to try to be in my swarm. I believe we might have a problem because basically from here you need to be able to see my internal network. Yes, so Patrick, I think that's mostly correct because you can't access that network. I will show you later on, maybe in later on, which is a very complicated stuff, how you can create a network inside Google Console, not just to keep this. Now the other people, please don't be confused from this. So here from the Cloud Platform Console, I could create my own network. And this network will be used as for these purposes, and I have to assign basically a specific IP address and so on. Okay. Now if you have a problem with the swarm like command not found, this means Docker is not installed. Yeah, so you have to see the lab for report and you install basically Docker in one of those VM, A quick hint, just to create an instance based on the custom image that I have for you. Okay? What else we need to do? Now we want to run those services and we want to scale them up. And we will create so many replica about those services. To do so now, before I start with the scalability, guys, do you manage to create a swarm and you add all nodes to the swarm? I have all the time. I don't want just to rush things. You can ask me if you have... Timeout was read before node joined. Yes, Steve, create your own manager and you will be fine. Now let me check this. Docker swarm join. I get timeout because there is network is not reachable. We need to create something called overlay network, but I don't think it's important now. Most likely we are fine if you can just create your own swarm with your own manager and we should be okay. Alright guys, can I do now the scalability part? All good? So for the people who are getting this problem with Docker, just go in the boot disk, change it to custom image and select this image. Yes, you need to do sudo Abdullah. You need to do sudo docker. Now for the people who are getting Docker not installed, just do this or go back to the... Oh, I have the command by the way. I still have it from the last tutorial. And to install it, you just run this command in the... Just to install Docker. If you just want to install Docker, you can run this basically straight away. Now let me just make this a little bit down a bit. Okay, so run the command, the first command and the second command, which is sudo usermod -ag docker username. We did this in lab 3, we did this in lab 4, and we should be able to do it now. That's right, yeah, that's the command. Amy, I think Amy who is having the issue. Yes, that's it. Okay, I think we will wait 5 minutes. So guys, I don't have lots of time, so I will carry on and you can see the recording if you are not with me. Times fly. Now, go back to the terminal. I will now go back to the terminal and be sure now you are doing this work from the manager. I wish if I could just say now host name manager. Hopefully. Maybe sudo. Okay, that's fine. Now to scale this swarm, now I want to scale all the services running in my swarm manager for a certain level, so I can meet the demand. Okay, after I create and I join, and at any case you just check docker node ls, this will give you this one. Now I will create now a service using this command, docker service create -replica, and this is going to be the site, my site. I'm going to run it with 10 replica, and this is going to be port 80, which is the host port. This is how I access it. And port 80, the other one, this is the container port, which is 5000. I will call it name my web or web, and this will be the name of the image that I have. Okay, so this should be the name of my image that I run in my container. Just to be careful, you better just do this. Just do this, Docker images first. Check what's the name of the image that you want to run, which is Baz app in my case, and now use that to scale. So in this command, guys, what I'm saying, can you read the font, guys, or you want me to increase it a little bit? Let me just make the font bigger. 14 is good. It's good. Terminal preferences. Terminal setting. And change. Maybe 16, 17. And that should be fine. Now Docker create service replica 10, and this is going to be minus P, the port of my host 5000. Now once you do Docker service, if I know how to type Docker, I will be good. Docker service, and now ls listing. I am listing all the replicated services. I have 10 out of 10 replica. What else I need to scale? Like, what do you think I should scale? I should maybe scale this Grafana, because I think the Grafana is not going well at all. So if I just go and scale, we paste on Docker PS. Now let me see, Grafana is running at port 3000. Okay, so I will go and do the same command, replicate, and this is minus port 3000. My graph, let me call it, and this is the Grafana, the name of the image. Now there is many ways how you do this. Also there is another way, which is basically you create a stack and you deploy a stack. So now I have Docker ls service, ls, and this will be creating a replica for my graph, latest, Baz, my app, and so on, and this will be scaling things up and down. And this will improve the performance of the server overall. Now if you look, you will see now, if you just do this command from the terminal to inspect, we have a service called web and we have a service called Grafana. Now look to my services, how they look like. I have manager 1, worker 1, worker 2, and things start to be assigned to them. So I have created many replica from the same service, from my web app, that little tiny monster app, I am replicating it. So each one in the swarm, like worker 1, worker 2, some of them running, some of them still shutting down, and things are just improving. You could also do this, you could do just Docker service, okay? And then you say scale. I want that service which called web, I want to scale it to 20. Maybe it's not enough to scale to 10. The same will apply, and you will see now it will create a service. Now I have 10 out of 20 running. Now it will improve and it will be like 20 out of 20. Once you go back and you test, this app will be much faster. Now it's restarting the service, so don't freak out. All the performance wise has been improved significantly because now I have so many people working with me. I have 2 workers. I could simply add a new one. I will just add a worker number 3 now, and I will ask this guy to join the swarm, and he will be assigned he will take his portion of the work as well. So I will just create this guy and I will add him to the swarm. If you have any question, guys, please ask me in the chat box. It's going to be a very interesting tutorial for you. And this is what we are going to do in the lab. So I'm not going to make a lab overview. In lab 5, what we will create a swarm. Now, there is a nice tutorial. If you just want to try this without the complexity of Google Cloud and the console, and you just want to do it at home, at VirtualBox, this is a nice tutorial I recommend doing. You will really enjoy doing this tutorial. It will create the whole swarm cluster using VirtualBox, and you will be able to see them and run a service on them, and you scale the service up and down and so on. So for lab 5, we will create a very tiny small little Flask application with 2 routes that I'm going to describe later just in a few seconds, and then I will do as well a swarm. I will have like a swarm with 3 nodes. I have manager, I have 2 workers, and now I will deploy this service into that swarm. This is what we are going to do in lab 5, just to let you know. So worker 3 is now ready. I just access worker 3 and I will show you what I do to make this worker joining the swarm. So I just do this little SS session, reload. Oh, it's here. Oh, shit. Okay. Now I want to add this worker 3 to the swarm, but how I can get the swarm token? You remember the command that we just bought, but I forget it. I lost it. How I could find it? This could be obtained by a simple command from the manager. All you need to do is just put the following in that manager. I will show you now how easy is that. Now from my manager, okay, I will do now docker swarm join token worker. Now give me the token that I need to run from any worker. Now go back to the console. Okay, now from the console just go back and access the SSH session. Wait for a few seconds. Now you can do it just only from SSH, but you will not be able to see the screen and it will be so complicated. Okay. Now I am in worker 2, so I will exit that. Be careful what you are doing, guys, there. So I will access, oh, no. Worker 3. Now I am in worker 3. He will create now SSH key and he will access this. Now all I need to do is just go back to the terminal, copy that lovely code that I just got by docker swarm join token worker and paste it here, and most likely I'm going to need sudo because I have not added sudo to this user. So the node has joined the swarm, all good. Now go back to the terminal again, and I am in the terminal, sorry, from the worker 3, all I did, guys, is just sudo docker swarm join the token. I paste that command, I hit run. Now go back to the terminal window. From the terminal window, now if you do docker node ls, you will be able to see that, oh god, worker 3 has joined the swarm. A simple inspection of service inspect, and I want to inspect the web service. Why I need to inspect it? I don't want to inspect it now. What I was doing, Docker service in PS ls. Now good. Oh, this service should be removed, so I will remove this service now, and I will tell you now why. Because it seems to be we are not running the right thing. So I will remove it. Okay. I will show you how you remove a service later on, which is Docker service rm, the name of the service, as easy as that. But now let me just check the service ps web. I want to see if worker 3 has been giving any work or not yet. Now look to all of these replication. You can see worker 3. No, so I will scale the service. I will scale it, let's say, to 40. Now Docker ps ls, come on. Now 2 out of 40. Now let me remove that Docker thing, and I will remove it, and I will create a new one out of that. Docker service. At any case, you just do help just to get all the command, and you'll see that there is one called remove rm. So rm, and just remove the name of the service because this is not working for some reason. Now go and check Docker ps. You will see now I have so many replication of Docker, and you will see if you go to the Chrome that you will have this monster app is running in very high performance, not like before. So the performance of everything is improving, and this is the good news about Docker service and the ability to do scalability in that simple manner. Now, if you ask me, in my age, in the stone age of deployment, as I call it, how we used to scale things, you will be really amazed how easy now, in like 5 minutes, I managed to scale a web service, I managed to scale the whole infrastructure. Now, in the old days, to do that, I have to make a list of all hardware that I need. I have to make a bid, and I have to advertise in the newspaper that I need like 5 servers. I need like, let's say, 2 firewalls, 2 routers. And if for example, my manager accepts all of that, and the company has money, or the ministry or the government organization has money to buy all of that. If all of that happening, I need to buy the hardware, install it in my site, upgrade it, and this will be stucking at the server room for many long hours. If you think my labs are really hard, I think you will be seeing in your real life more than that, and you'll say, oh my god, labs were like just a joke. And you'll be stuck in there just to upgrade and scale the service. You'll be stuck in you'll be talking about 6 to 1 year at least. Like, if I am not going to be very optimistic about it, I think you will need at least 1 year to scale a service in the old days. Now, with a click of the button, few commands, you will have loads of virtual machines running different type of containers, a stack of containers, and you just simply scale them up. As simple as that. And you can also simply scale them down. As simple as you scale them up, you just scale them down to 5. That's it. So Docker service ls. Now I have only 5 replica because I don't have demand. Even with something like Alert Manager and all of these technology that I just show you, and with something like a Grafana and Datadog, for example, you could do the whole thing, the scalability. You can just scale things. You can just make the Alert Manager based on the demand, the dynamic demand that you are getting onto the service, scale, and add the new container or remove a container. And this is what we call load balancer. And this is why we need an orchestration framework like Kubernetes, which is somebody who makes that the whole component nodes in the Docker Swarm could speak with each other, orchestrated, and they can cooperate and collaborate to work in a single or many tasks. So this is why we need, guys, containers. This is why we need Docker Swarm. This is how you scale a swarm. This is how you create a swarm. This is why having a Docker Swarm a super interesting and a very interesting technology that we have today. And what I show you today is all edge technology. Now, what we are using now, what I just show you now, the people in Google, in Netflix, wherever you call, anyone in the real industry, my friends who works in Huawei or any large sophisticated technology, they just use the same. This is the tools that they use to create a swarm and upgrade and scale the services. Now, hopefully next week we will start to study this from different angle, which is Docker Compose, and we will see how we can compose a simple web application with a backend service, which is a server, maybe a database server, and we will start to sell chocolate ice cream online. And then we'll see how we can scale this, and we will put it under stress, and we'll see how we can scale this up and down. So that's all I want to say for today, guys, from my side. You will have this video in Classroom page. Go back, do the tutorials, follow the steps, and you don't need to worry about that. For interested cloud warriors only, I would maybe push everything I have to create all this sophisticated technology to GitHub, and maybe you can clone it and you just deploy it in one single click. I will try to make it as smooth, easy as possible, but this is not basically recommended or used in the lab. If you check to Slack now, you will see that my alert manager just sent me something happening at my service. So if you go to general, there is high CPU load in node exporter, which means one of those node, he said high node exporter. There is a high CPU node, definitely. I can see that. Just click here, you will see that high CPU node in this container, and he just informed me in Slack that there is an issue with it. Now, attendance. As we did last week, write your student number here so we can basically, yes, it is a load balancer, not only load balancer, now more than just load balancer. It is a load balancer. It is somebody who balance things, but it's not only that. There is so many interesting things happening at the background. Now, all of you write your student number here so we can take your attendance. I want to see your performance. And just to let you know, from last question that I posted in the classroom page, and any reflective component I am putting, like lab report, feedback, even if I ask you, do you hate my shirt color or not? You have to answer that. You have to take this seriously. So I'm allocating 10 marks of the CA to that reflective learning component that I want you to enhance and I want you to master. No question, guys. If you have a question, ask me, and we will keep this channel. It sounds fancy, so we can use it in the lab room. I will use it definitely. So keep this channel. We have like up to 10,000 message for free. And next time I might going to just paste some codes and just check how things going with people. Thanks for joining me today. Looking to see you all in the lab. Next week lab is going to be Docker Swarm, so it's worth just doing this tutorial. Not watching the tutorial. If you don't see the tutorials, as simple as that, don't come to the lab. You are wasting your time. Okay guys, see you all next week. Bye bye.